Hello students, today we are going to do class 10 triangles, that is exercise 6.5. We'll continue further with the sums. As we all know, we are doing in this exercise 6.5 dealing with Pythagoras theorem, converse of Pythagoras theorem, and also similarity of triangles if required. Now see exercise 6.5 question number 11 here. The question number 11 says that, here I'll just make the screen little less. An aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? So here we come to know that there are two planes which are starting at the same point. See, we come to know at the same time. So one aeroplane is flying to the direction of north and other aeroplane is flying in the direction of west. They have given the speed. The speed of the aeroplane which is flying due north is 1000 km per hour. That means in 1 hour it is covering a distance of 1000 km. Another aeroplane which is flying due west, it is flying at a speed of 1200 km in 1 hour. They are asking that after 1.5 hours, what will be the distance between the two aeroplanes? So let us assume I have just drawn the direction, so that's very easy for us. So let's take the point of intersection, this be as O, and we all know that when they are flying here, they will form a right angle triangle. So let's assume that the aeroplane which is flying from this point O in the north and the west, they start. So they meet after 1.5 hours at the point N. After 1.5 hours, suppose for example, the plane is meeting at the point, after 1.5 hours, the plane reaches at the point W. Then we have to find out NW. So actually we have to find out the distance covered by the aeroplane in the north direction in 1.5 hours, how much distance is covered. Because we already know that, we already are aware that in 1 hour, how much is the distance covered. So now we need to find out for 1.5 hours, how much is the distance covered. So when we write the solution, we can write very easily. So here it is just a simple Pythagoras theorem. Only the interpretation we have to do here. So here we'll write distance covered by an aeroplane. Distance covered by aeroplane in 1 hour. So in 1 hour, in the north direction, it is given as 1000 km per hour. 1000 km. So in 1 hour, the distance covered is 1000. So can we find for 1.5 hours? Yes. Therefore, distance covered in 1.5 hours. This 1.5 can be converted mixed fraction, right? So 3/2 in north direction if you want to find out. So just we'll multiply 1000. Like for one chocolate it is 2 rupees. So now the same way if 3 chocolates will multiply by 3. So here it is 3/2 hours. So here we can cancel 2 5s are 10 0 0. So we get 1500 km in the north direction. So we got the distance covered in the north direction in 1.5 hours by the aeroplane is 1500. So here we can just mention this distance is nothing but ON. Similarly, can we find the distance covered in the west direction? So here we can write distance covered by the aeroplane, distance which is covered by the aeroplane, in 1 hour in the west direction. In west direction, it is already given that it is 1200 km. It is 1200 km, as you can see. 1200 km, correct? So here we can write equals to 1200 km. So can we find out the distance covered in 1.5 hours? Therefore, distance covered in 1.5 hours equals to 1200 into 3/2. So here 2 6 are 12 0 0. So here it is 1800 km. So here we come to know the distance covered by aeroplane in 1 hour. In the west direction is 1200 km. Therefore, distance covered in 1.5 hours is 1800 km. And this distance we have marked as OW. Naming can be anyhow, so 1800. So now simple simple Pythagoras theorem will apply and find out what is NW. Therefore, here I'll just continue in the red so that it is there. So therefore, in right angle triangle, NOW, we apply Pythagoras theorem. So NW square is our aim to find out is ON square plus OW square, students. So what is ON square? 1500 the whole square plus 1800 the whole square. So 15 square is nothing but 225, and here the students it is square. So here 2 zeros, the 4 zeros will come. Similarly 18 square is 324, again 4 zeros will come. So here we had 4 zeros, and here we can add 5 plus 4, 9, 4, 5, 49. So let's find the prime factorization of 549, students here. So here we'll get 3 ones are 3, 2, here 3 eights are 24, 3 threes are 9. Again 3 six are 18, 3 ones are. So here we can write this as 549. Here 4 zeros we can split. So here 549 into, we can write 100 into 100, because ultimately we are going to take the square root. And here this 549 can be split as 3 into 61 into 100 into 100. So let's take the square root and get the answer, students. So here we get NW square here, NW. So taking square root, we will get 3, 1 3 out of the 2 3s, we can add 1 3, 61 will not get, out of the 200s we'll add 100 and we'll get 61. So here we will get 300 root 61 kilometer. So at the last, we have to write the final answer. Therefore, the distance between the two aeroplanes, after 1.5 hours. Distance between two aeroplanes after 1.5 hours, you can find that it is 300 root 61 kilometer. I hope this question you have understood. It is just a simple Pythagoras theorem. So the first thing we have to interpret the diagram. Once we interpret the diagram, then it becomes very easy. So we know in this direction for 1 kilometer to 1 hour it was given. So we have found out the distance covered in 1.5 hours. Similarly, in the west direction, the distance covered by the aeroplane in 1.5 hours, and this simple Pythagoras theorem, and we got it. Let's move to the next sum, students. And the next sum here is question number 14, which I'm going to do it here. Just one sec. So question number 14, it says that the perpendicular from A on side BC, the perpendicular from A on side BC of triangle ABC. So there is a triangle ABC. The perpendicular is from A to the side BC. So here AD is perpendicular to BC, we come to know. There is a relation given that BD is thrice of CD. BD is thrice of CD, and here it is given, prove that 2AB square equals to 2AC square plus BC square. So here it is given that perpendicular is drawn from A on side BC and of triangle ABC such that DB is thrice of CD. Prove that 2AB square equals to 2AC square plus BC square. So let's analyze here. Given is that here DB is thrice of CD. So can I assume this as X? If CD is X, I can get this as 3X. So we got a relation. CD is X, so BD is 3X. Now we have to find out 2AB square equal to 2AC square plus BC square. So LHS equal to RHS. So here we can just find out, either I can take LHS and manipulate my LHS such that I get my RHS. I can consider LHS and then I will take AB square. I will find what is AB square and I will manipulate my LHS such that I get AC square and BC square. Or you can consider RHS and you can manipulate the RHS and bring it to LHS. Any way you can do it. So let's start from, I'm going to start from LHS. I will find AB square. I want AB square means which right angle triangle should I take? It's very clear, ADB. Then after taking consider triangle ADB, I will get AB square equals to, right? So let's start with the proof. So students, here we come to know. Okay, first I'll just write let CD equal to X we have taken. If CD is X, therefore we get BD or DB equals to 3X. Correct? So if DB is 3X, can we find what is BC? Yes. So BC can also be found out CD plus DB, that is X plus 3X, that is equals to 4X. Now let's take, as we said, we'll just take LHS. LHS is AB square. So for AB square, I'll consider right triangle ADB. So if I consider right triangle ADB, so AB square equals to AD square plus BD square. Now I will manipulate my RHS so that I get AC. I don't want AD, but I want AC. I don't want BD, I want BC. So that we can do very easily. So AD square, can I bring this AD square in terms of AC? We want AC. So AD square also exists in triangle. If I consider Pythagoras theorem in triangle ADC, I can write instead of AD square, AC square plus minus CD square, correct? So here I write number 2. So I get this. So here I'll consider right triangle, students, triangle ADC. So if I consider right triangle ADC, I will get AC square equals to AD square plus CD square. So instead of AD, I can write that AD can be written as AC square minus CD square. So here we have AC square minus CD square equal to AD square. So why we are doing this? Because in RHS we are interested in AC square. Now here I'll write number 4. So I can replace this AD square with AC square. So here we are doing AB square equals to, so instead of AD square, students, I'm writing in terms of AC. So I can write AC square minus CD square plus BD square. So here I will write the reason from here. This is from 2 and 4. So just a quick recap, we wanted AB square, so we took triangle ADB and we got AB square equals to AD square plus DB square. Then I don't want AD square in my RHS, I want AC square. So for that I will consider triangle ADC and instead of AD I will replace it with AC. So therefore in right angle triangle ADC, AC square equals to AD square plus CD square, hypotenuse equal to sum of the squares of the other two sides square. So I had kept AD here, took CD this side. So sign of CD changes. So AC square minus CD square. Now can I just see and compare? So I have AB square, students. I have AB, I have AC. Now I just want BC. So can I substitute instead of CD x square? Can I see here x is there? Yes. Instead of BD, can I put 3x? Yes. So we can just substitute here. So AB square equals to, students, here we have AC square and here I will write x square and here I'll write 3x the whole square. Now 7th step, I'll just continue here so that we understand. So here 7th step, here I'm writing AB square equals to, here we get AC square minus x square, 3x the whole square. 3x the whole square will give you 9x square. So here we have AC square plus 9x square minus x square will give you plus 8x square. So we have here AB square equals to AC square plus 8x square. I want 2AB square, 2. So if I want 2AB square, I need to multiply on LHS and RHS. I have AB square, so I'll multiply by 2 on both the sides. So I'll get 2AB square equals to 2AC square plus 2 into 8 will give you 16x square. I hope this is very clear. We are just trying to manipulate according to what we require. Now check, we have 2AB square, we have 2AC square and we want BC square. Now what is 16x square? Can I write? I know BC is 4x. BC is 4x. So this can be easily written as 4x the whole square. So now it's become so simple that we got 2AB square equals to, so here we have 2AB square equals to 2AC square plus here we have 4x can be written as BC square. So thus we have proved very easily that LHS equals to RHS. So here we have just substituted to Pythagoras theorem and just you have to focus what we require. I have concentrated in LHS and manipulated my RHS according to what we have to prove. Thank you, students.